What up? Let's do this. Review. You might need an extra sheet of paper to do all this work. So if you have it, get it out. Got a lot of stuff to do. I'm going to pull up also the identity cheat sheet that we created in class today. That way we can reference it. Right here. Okay. So like all of these guys. Whew, it's a lot. A lot. It's all right. We can handle it. So number one, got tan A is 20 over 21. Sine A is negative. BB angle with cosecant of B is 5 and cosine B is negative. Find sine A minus B, cosine A plus B. I'm just going to go ahead and start with the identities. So I got sine, cosine, cosine, sine. Same sign. So that's a minus in here. So it's going to be a minus here. Sine, cosine, cosine, sine. And then this is cosine, cosine. Flip the sign, sine, sine. It's like one of the only ones I remember from high school. I don't remember any of these other ones besides sine squared plus cosine squared equals 1. That's the one that's like the key one. All the double and the half, I don't remember. So we kind of do this problem later. We're given two angles, A and B, which means we need two triangles set up. I need tangent to be positive, but sine is negative. Okay, that's in the third quadrant. And tangent's opposite over adjacent. So opposite, if my angle's right here, and this is A, I can write A right there. Opposite's 20, adjacent's 21. Use your friend the calculator. Let's get out my friend the calculator. Come on, friendly calculator. There it is. Okay. There's my friend the calculator. And you can use the Pythagorean theorem. Remember Pythagorean theorem? A squared plus B squared equals C squared. C is the hypotenuse always. So I need 21 squared plus 20 squared. And I need to square root that. Oh, look at that, 29. Let's see. Now, I'm going in the third quadrant, so I'm going left and down. So I put those as negatives. From there, we can find the sine and the cosine and the tangent of my angles. Angle A being there. For cosecant is 5. Cosecant reciprocal of sine. So that means sine B would be 1 over 5. Cosine's negative, sine's positive. Second quadrant. So opposite over hypotenuse. The opposite's got to be 1. The hypotenuse has got to be 5. We end up with 5 squared minus 1. So it's like A squared plus B squared equals C squared. C squared is 25. I don't want to show this. I'm going to show this once, but then after this, like you guys should know, like A squared plus B squared equals C of the hypotenuse squared. This is 25 minus 1, which is 24. Square root of 24. I mean, you could leave it as square root of 24. It is root 4 root 6, which is 2 root 6. I don't know. I know we're going to the left, though. Okay, from that, you can write sine of A, and this is angle B. Sine of A, opposite over hypotenuse, negative 20 over 29. Cos B, cosine of B, negative 2 root 6 over 5. Minus cosine A, negative 21 over 29. Sine B. And how am I doing this? It's like opposite. It's like SOHCAHTOA. So like sine of B, opposite over hypotenuse. 1/5. Okay, double check. Sine A, negative 20 over 29. Cosine B, okay, adjacent over hypotenuse, negative 2 root 6 over 5. Minus cosine A, negative 21 over 29. Sine B, 1/5. Okay, cool. In terms of simplifying this, what you'll find is that the denominators are the same. The denominator is 29 times 5. And then over here, I got negative 20 times negative 2 root 6s. I'm not going to worry about that root 6 multiplying that because I'm just going to say it's 40 root 6 over 145. And then this is minus a negative. So this is a negative number. That'd be adding a positive. And my final answer I'd probably write is 40 root 6 plus 21 over 145. The actual test, you're probably going to see questions where it might not be this messy and it's going to be multiple choice, but you're going to have to be able to like multiply things together and select the correct answer. All right, cosine A, cosine B, minus sine A, sine B. So cosine A, negative 21 over 29. That's adjacent over hypotenuse. Cosine B was negative 2 root 6 over 5. We are multiplying these together, okay, not subtracting. Minus sine A, 1 over 5. Sine B, see, this is tricky. Sine A is negative 20 over 29. This wouldn't have mattered anyways because like the order of things and multiplication doesn't matter. Sine B, 1 over 5. Again, you get 29 times 5 in the denominator, so that's 145. Negative 21 times negative 2 is positive 42 root 6s. And then this would be plus 20 over 145. So you could rewrite this as 42 root 6 plus 20 over 145. You want to feel good about yourself? Never mind. I'm not going to show you how to check this. It's like not worth it. It's going to confuse you. Okay. Double angle formulas. So we got an angle in the third quadrant. So here's my angle in my third quadrant. Make sure we're like understanding things correctly. I got a bunch of stuff. I might as well find the sine value. So using Pythagorean Theorem, I should have 65 squared minus because it's the hypotenuse. So 16 squared plus b squared equals 65 squared. Gosh, I don't want to show this. I feel like you guys should be good with this, but I just can't shake the feeling that one of you is like, how the heck did they get that? 65 squared minus 16 squared. Make sure you're not typing negative 16 squared. That's wrong. Like, I know a negative number times a negative number is a positive number. Your calculator is deceiving you here. That's why I use parentheses. Anyways, that's why I have minus. I don't have a negative here because it's like I know negative 16 squared is positive 16 squared. Anyways, what's the square root of 3969? 63. Look at us picking up these Pythagorean triples here. It's going down, so that's negative. All right, sine 2 theta. This is the only one I remember. It's 2 sine theta cos theta. You guys just double check with your cheat sheet, okay? So it's a double angle, 2 sine theta cos theta, okay? And back here, sine of theta. Opposite over hypotenuse, negative 63 over 65. Cosine theta, adjacent over hypotenuse, negative 16 over 65. Calculator. Come on. So that's 2 over 1. So, I mean, you could do it all at once and then just have them simplify it for you. What do I do? I just told you to do it all at once. And then I don't do it. Can I use my? No. Try to use my. Yeah, I guess I can. Okay. You get that. You can use the fraction button. You don't have to math that or enter it. Yeah, that doesn't simplify. 2016. Great summer. Great year. 2016. 4225. Cosine 2 theta. This is one where you have multiple. You have either like cosine squared minus sine squared or 1 minus 2 sine squared or cosine squared a minus 1. It's your choice. You already have, mean, you have anything you want. Pick one. 2 cosine squared A minus 1. So, understand 2 cos squared angle minus 1 is the same as 2 cosine of my angle squared minus 1. So it's 2. The cosine of my angle is adjacent over hypotenuse, negative 16 over 65 squared minus 1. Type that into your calculator. 2, negative 16 over 65 squared minus 1. Math generator. We're not messing around here. Tangent 2 theta. I don't know this one. 2 tan A over 1 minus tan. Oh, I do know this one. It's from the sum. It's tan A plus or minus tan B. Well, it's tan A plus tan A over 1 opposite sign, tan A, tan B, like multiplied. So that becomes tan squared. I should have remembered that. Okay, so this is 2 tangent theta over 1 minus tangent theta quantity squared. Tangent theta is just negative 63 over 16. That's positive. So we can have 2 times 63 over 16 over 1 minus 63 over 16 squared. Woo! Be glad you're not doing this by hand. I don't know. Probably back in the day, I would tell you guys to split this into 2 different things and then divide them. But with this friend your fraction button, does this have the fraction button? Yeah. You can just be like, 2. Let me throw another fraction up here. Woohoo! No, 2 times. I guess now I have to do the fraction. 63 over 16. This is soft, to be honest. I'm not gonna lie. You gotta be able, if you're going to be working with computers, and you kids that do work with computers, you gotta be able to understand how to use order of operations and how to type things in. I get a negative. I guess that makes sense. Doubling this angle might put me in a quadrant that tangent's negative for. Now, the 2016, great year. I feel like this is wrong. I want to do it myself. Sorry for taking so long with the calculations. But you kids love your answers. Okay, half angle formulas. These are with the cos squareds and the sine squareds. Sine of theta over 2. Plus or minus, depending on our location. We'll have to talk about that in a second. My location's in the 3rd quadrant. But what's theta over 2? I don't know that answer. We'll talk about it in a second. I got plus or minus root 1 minus cos A over 2. I mean, I'm in the 3rd quadrant. Let's say it's it's a big Y, it's a small x. Honestly, this triangle should be down like this. So it's close to, this is 180, this is 270. So it's probably 260. If I take 260 and divide it by 2, and I could show you how to get the angle, I'm just not even going to bother. I get 130. Okay, so 130 is in the second quadrant, which is why I'm thinking that the cosine value is negative. The sine value in the second quadrant is positive. So I think this answer is positive based on theta over 2. Now, guys, I would give you full credit if you gave me either of the answers for this specific problem, because it's not obvious what this angle is located and what it is. So like this divided by 2, depends on what the angle is. If you divide it by 2, if it's bigger than 90 or less than 90. Let me think about it. Greater than 80 or less than 270. It's in the third quadrant. So yeah, I think it's always going to end up in the second quadrant, because if you have something that's 180 divided by 2, that gives you 90. But if it's greater than 180, that means it's going to be bigger than 190. If it's less than 270. Yeah, so okay, I'm going to go ahead and say, yeah, we have to know that we are going to be located in the second quadrant. I know that based on any angle anywhere between 180 to 270, which is in the third quadrant. Dividing that by 2 gives you an angle from 90 to 270 divided by 2 is 135. So that puts you definitely in the second quadrant. Because it's second quadrant, sine's positive. Okay, so you got to know that. I didn't really talk about that much in class. So I definitely give you lots of partial credit if you didn't get this right. Cos theta was 16 over 65, so I have the square root of 1 minus 16 over 65 over 2. That becomes square root 1 minus 16 over 65 over 2. Yeah. You could do some stuff with this, but that's fine. You can say this is the square root of 49 65ths over 2, which is the square root of 49 over 65 times 2 is 130. And say that's like 7 over root 130. Square root of 49. Let's say 7 over root 130. Yeah, that's the answer we're looking for. Right there. But are you going to have to, I think the numbers that you're going to be using end up working out easier. Like, do you have to rationalize this? Root 130, root 130. And get 7 root 130 over 130? I don't think so. All right, cosine theta over 2. Cosine theta over 2 is plus or minus, based on the angle over 2 location, 1 plus cos A over 2. So it's a 1 plus instead of a 1 minus. We got this from the cosine 2a formula, how to get the square root formula. So you guys know where it comes from. Now you got to know how to use it. Plus or minus, that is the question. Well, again, if you start with something between 180 and 270 divided by 2, you're going to be between 90 and 135, which means you're in the second quadrant, and the cosine of an angle in the second quadrant is negative. That's important. And then cosine theta is, I'm not going to bother simplifying. This is like getting a little bit ridiculous. Is negative 16 over 65. It's like root 1 plus negative 16 over 65 over 2. Simplifying is like, that's not what we're doing here. It's like that. You can type that into your calculator and get your answer. Tangent. One of these. This one, this one, this one. I like that one. Nobody likes minus signs. Sine A over 1 plus cos A. So sine A over 1 plus cos A. So this is sine theta over 1 plus cos theta. That is negative 63 over 65 over 1 plus negative 16 over 65. And like this is annoying. Negative 9/7. Could have done that. This is 65 65ths. 65ths would cancel. We'd be able to simplify that, but whatever. Okay, so lots of work for those first two problems. Number 3, verify the identities. We did these in class. I'll just show them to you again. I see cotangent, I see cosecant. There's multiple ways to do it. I see the parentheses. It's like I feel like I gotta distribute. That's like my first instincts. And I get cosecant, and remember, when you're verifying an identity, you kind of don't work on the right side. You just work with the left side, and you know what your answer is supposed to be. So you get cosecant squared x minus cosecant x times sine x. Well, that then leads to cosecant squared x minus, it's like, well, I could either turn sine into 1 over cosecant, or I could turn cosecant into 1 over sine. Either way, those things cancel, and that turns into cosecant squared x minus 1. And then, understanding my identity for cosecant squared, 1 plus cotangent squared is cosecant squared. And I showed you how you should be comfortable with like manipulating this by subtracting things, moving things around. Cosecant squared minus 1 equals cotangent squared. So I would actually stop here and say that equals cotangent squared. And that's fine for showing things. Here, this one is really tricky. We showed this in class. So we need this to equal sine squared. This is a situation where like maybe it is advantageous for us to rewrite things in terms of sine and cosine. So I wrote secant as 1 over cosine. I wrote tangent as sine over cosine, and cotangent as cosine over sine. It's like, do I write this as tangent? How do I divide? Like this plus really complicates things. You can't divide tangent into tangent and cancel. Like a lot of people might think, oh, that's tangent up top. Doesn't that tangent cancel with this tangent down below? No, it doesn't. That does not cancel because of the addition. Okay, you need to be factored. You need to have multiplication to cancel. Common mistake made is that. Don't do that. You're not allowed to. It's like, tell me, is like 2 over 2 plus 3 the same as 1 over 1 plus 3, which is 1/4? It's like, no. This is 2/5. 2/5 is not 1/4. This is 0.4. This is 0.25. So what do we do? Whenever we have addition in these things, it's important to try to combine them using a common denominator, which means you multiply the other fraction by the denominator, the top and bottom, by the denominator of the other one. So it's like I'm multiplying this one by this denominator. I'm multiplying this one by that denominator. So what do I get? I get like 1 over cosine theta times sine theta. And in the denominator, I get sine squared theta over sine cosine plus cos squared theta over sine cosine. Okay. Now, when you have a common denominator, you're allowed to add the numerators together. So I have 1 over cosine theta times sine theta in the numerator. In the denominator, I have the numerators that can be added together over the common denominator. Now, the thing I notice is this sine squared plus this cosine squared. We know that sine squared plus cosine squared is 1. It's the Pythagorean theorem. A squared plus b squared equals c squared in the unit circle when the hypotenuse is 1. So I'm replacing sine squared plus cosine squared with 1. I got 1 over cosine theta sine theta over 1 over sine cosine. Now, dividing fractions is the same as taking the numerator, multiplying by the reciprocal of the denominator. So that'd be sine theta cos theta over 1. What should we do now? Well, combine all these fractions. Like this is a sine over 1. Multiply the numerators together. Since this is multiplication, you can do this. It's not done with addition. Multiply the denominators together. What happens? We get sine squared theta cosine theta over cosine theta. This is multiplication, which makes it easy to simplify. I get sine squared theta, which is what I'm looking for. It's involved, man. It's tough. What's the tangent of 75 degrees? Well, I don't know. You want the exact value, right? Try to use your calculator. Calculator's not going to give you an exact value. It's going to give you a decimal. You need to figure this out using the summation. Pick two angles that you do know the tangent of. I know the tangent of 45. I know the tangent of 30. So tangent of 45 plus 30 is how I'm going to treat and take care of the tangent of 75. Summation. We got tangent, same sine plus tangent over 1 minus, which would be the opposite sign, the product. Need to figure out. Tangent 45, we know this, 45 degrees. First quadrant, root 2 over 2, root 2 over 2. So the tangent is 1. It's root 2 over 2 over root 2 over 2. Tangent of 30, that's something I got to just remind myself of. I don't have the tangent values memorized. So 30 degrees is our short 30, 60, 90 triangle. Our short side is the 1/2. Our long side is the root 3 over 2. Tangents opposite over adjacent. So it's 1 over 2 times 2 over root 3. That's 1 over root 3. That's root 3 over 3. You don't have that memorized. Instead, you know how to get it. 1 over root 3 over or root 3 over 3, depending on what we need, will work. I don't care if you write 1 over root 3. It's just you might have to rationalize it later. There are multiple choice questions. Usually all the answer choices are rationalized. So here we go. We got 1 plus, I'm going to keep it as root 3 over 3, over 1 minus 1 times root 3 over 3. I kind of want to simplify this more. I'll turn this into 3 over 3. I'll turn this into 3 over 3, giving me 3 plus root 3 over 3 over 3 minus root 3 over 3. Right? That 1 is just goes away. And what I notice is I got 3 plus root 3 over 3 times 3 over 3 minus root 3. The 3's cancel. I get 3 plus root 3 over 3 minus root 3. Don't believe me? This is when you can check and have fun. Like, this is what I would recommend you do. It's like tangent 75 degrees. Be careful. Tangent 75. That 3 plus root 3. 3 minus root 3. Oh, look at that. It's the same number. Loved it. All right. Find the exact value of sine 5 pi over 12. Well, remember, folks, we did this in class. Pi over 4 is the same as 3 pi's over 12. Remember, pi over 6 is the same as 2 pi over 12s. Maybe on your test, you might have to use pi over 3, which is 4 pi over 12s. Okay? Combining these two in some way to get this is the key. 3 plus 2 pi over 12s gives us 5 pi over 12s. I'm going to do sine of pi over 4 plus pi over 6. Okay? Change this into a summation. Sine of two things being added, sine, cosine, same sign, cosine, sine, keeping the angles in the same order. Sine of pi over 4 is root 2 over 2. Cosine of pi over 6, 30 degrees, short 30, 60, 90. Cosine adjacent, root 3 over 2. Hypotenuse, opposites 1/2. Cosine pi over 6, root 3 over 2. Cosine pi over 4, thankfully the easy one, root 2 over 2. Sine pi over 6, that's the 1/2. Giving me root 2 times root 3. I can do root 2 times root 3, just like I can do root 4 times root 9. That's root 36, right? That makes sense. Root 4 is just 2, root 9 is just 3, root 36 is 6. That's good. What I can't do is root 4 plus root 9 and tell me this is root 13. Square root of 13 is not 2 plus 3. I should get 5. So don't do any simplification with addition, just multiplication. So this turns into root 6 over 4. This turns into root 2 over 4. This turns into root 6 plus root 2 over 4. Same deal. I can check it using my calculator. Turn your calculator into radian mode. Blah, 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 blah. Okay. Oof. What do these equal? I need some space here, guys. Now, a lot of these are simple. A lot of these are like, hey, look at your identities. A lot of them will simplify easily. Okay. Okay. Secant squared x minus tan squared x. Let's look. There's secant squared and a tangent squared. Whoa, whoa, oh, look at that. Hold on a second. Secant squared minus tangent squared. Okay, secant squared. I could subtract tan squared. Don't go crazy, guys. Don't start changing things into sines and cosines. Slow down, hit the brakes, check things out first, and then be like, oh, okay, I got it. That's just one. Boom, one. Cotangent over cosine. Okay, well, now, like, what do you want to do? There's a lot of things you could do. Like, you could rewrite it already in, like, fraction form. Sometimes what I like to do is like, move things around. Like you could rewrite this and then say it's like, okay, cosine x over sine x times 1 over cos x. You just get 1 over sine x, which is probably what they want to say is cosecant. You can get that way. I kind of sometimes like, and it depends. I sometimes like to rewrite things like this is cotangent x times 1 over cosine x, just to keep everything on one level. That way I don't have fractions inside of fractions. So cotangent x over 1, that's like 1 over tangent. Or I could just say like cotangent is cosine over sine. So I turn into cosine x over sine x times 1 over cos x. You know, if you multiply these across, that'd just be one fraction, and you can cancel the cosines like 2 times 1 over 2. It's no big deal. Again, giving you 1 over sine, which is cosecant. Okay, so that's the next one. This third one. Yeah, cosine squared x plus. What's cotangent squared? I mean, this one I can just see. I'm going to multiply these together. So watch what happens if I multiply these together. Cosine squared over sine squared. Cosine squared. Hold on a second. This is not what I thought. I thought it was going to be easier. That's like cosine to the 4th. Don't like that. Are you sure it's that tangent? I guess not. Let's see what happens. Is this negative? See, look, sometimes I struggle with this. I'm going to factor out cosine squared. If I factor out cosine squared, it's like x squared plus yx squared. X squared gets factored out. You have 1 plus y, right? So cosine squared gets factored out. I have 1 plus cotangent squared, okay? So I think 1 plus cotangent squared is something we should know. 1 plus cosecant squared. Cosecant squared. So this is cosine squared x times cosecant squared x. Cosecant's the same as 1 over sine. So this is cosine squared x times 1 over sine squared x, which ends up being cosine squared x over sine squared x, which is cotangent squared x. I think that's right. 1 over cotangent could either be tangent or it could be sine over cosine. I don't know, we'll figure it out. Root 1 minus cosine squared. Well, what's 1 minus cosine squared? 1 minus cosine. Okay, if I subtract cosine squared, I get 1 minus cosine squared. Okay. 1 minus cosine squared is equal to sine squared. Okay. So this is root sine squared. Square root of sine squared. Sine. All right. Well, let's see. I think for this, it's A. I think for this, it's cosecant C. I think for this, a tricky one, cotangent squared. F. I think this is just tangent. G. I think this is just sine. J. Next set. It's gonna be a while. But this is gonna be your toughest test yet. Sine over cosine. Easy. Tangent. Secant, cosecant, tangent, -1. What? Listen, this is all set up for something -1. Secant is 1 over cosine. Cosecant is 1 over sine. Tangent is sine over cosine. If you multiply everything across, what you'd be able to do is cancel the signs, and you'd get 1 over cosine squared. So this turns into 1 over cosine squared -1. 1 over cosine squared is secant squared. Secant squared -1. Go back to your thing. Secant squared -1, tangent squared. So subtract the 1, secant squared -1, tangent squared. Oh yeah, that addition's gonna be tricky. Okay, here we go. I'm rewriting tangent as sine over cosine. I'm just gonna do it right here. You're adding two fractions together. Common denominator. That means I'm going to multiply the top and bottom of this one by the denominator over here. Over here, I'm going to multiply the top and bottom by the denominator of the other guy. Okay, now, this guy on the left, cosine squared x over cosine x, 1 plus sine x. This guy on the right, sine x times 1 plus sine x, and cos x times 1 plus sine x. I can distribute the sign. I'm going to do that. That gives me, I'll go right here, and I can also add everything together. Cosine squared x plus sine squared x over the common denominator of cosine x 1 plus sine x. Now cosine squared plus sine squared right here. Cosine squared plus sine squared. That's 1. So this turns into 1 plus sine x in the numerator. The denominator, it's cos x 1 plus sine x. What? 1 plus sine x. Because it's the entire thing, and because this is multiplication in the denominator, I can cancel that. This one was the toughest one so far. That's 1 over cosine. That's secant. So we got that one as secant. 1 plus sine squared is cosecant squared. I'm pretty sure that's going to be an answer. That's nice. 1 minus cosine squared. Look at this guy on the right. 1 minus cosine squared. 1 minus cosine squared is sine squared. So wait, hold on a second. Is it turning into 0? Yep. This is sine squared. This turns into sine squared. Sine squared minus sine squared, 0. Let's see. First one, I think is tangent. Tangent, G. Yeah, I guess so. This guy, tangent squared, E. Wish this made one of those funny joke things. This guy, simplified all the way down to secant. That was a tough one. Common denominator, secant, D. Cosecant squared, that's easy. E. 0, Q, 7. All right. Same kind of deal as we've done before. These are annoying. I feel like we've already done these. Can I skip these? Can I skip them? No. Jerks. All right. Well, cosecant x is negative 5 over 4. We're in the third quadrant. Cosecant's the reciprocal of sine, so sine's going to be negative 4 over 5. Opposite over hypotenuse, hypotenuse over opposite. Third quadrant, opposite, negative 4. Hypotenuse is 5. At least it's nice that this is 3. I think I did this in class. Whatever, I'll do it again. Sine 2x is going to be 2 sine x cos x. That's 2 times the sine of x is negative 4/5. The cos x is negative 3/5. At least it's not like crazy numbers. So that's 12 times 2, 24, 25ths. Cosine 2x. Which one do you want to use? Cosine 2x. Cosine squared minus sine squared? Probably not. 2 cos squared a minus 1? Yeah, maybe. Yeah, let's do 2 cos squared a minus 1. 2 cos squared. That's cosine x quantity squared minus 1. That's 2. Cos squared is negative 3 over 5. Squared minus 1. That's 2 times 9/25 minus 1. That's 18/25 minus 1. That's 25/25. That's negative 7/25. Do it in your calculator. Check me. I'm right. Actually, 9/25. 18/25. 25/25. We could check with another version. We could do the cosine squared minus the sine squared with our calculator. That's a good way to check because I don't feel confident. So. All right, so the cosine squared would be negative 3/5 squared minus the sine squared is negative 4/5. I don't have to put the negative in here because I'm squaring. I don't know why I'm doing it. Okay, tangent 2x, that's 2 tans in the top because it's tan A, and then 1 minus tan squared or tan x squared. Tangent is negative 4/3, so that's a positive 4/3, opposite over adjacent. So 2 times 4/3 over 1 minus 4/3 squared gives us 8/3 over 1 minus 16/9. 9/9 minus 16/9 is negative 7/9. So this is 8/3 over -7/9. This is easier than using my calculator, to be honest. That is 8/3 times 9 -7ths. This cancels to be a 3 in the numerator. This is 24 over -7. Yikes. Half angles. Yay. This is a doozy. I like it. I don't even remember the half angles. Okay, plus or minus root 1 minus cosine over 2. Okay. Plus or minus root 1 minus cosine A over 2. What is it, plus or minus? Well, we're in the third quadrant. Okay, I learned how to figure this out. Third quadrant are angles between 180 and 270. Divide them by 2, you get angles between 90 and 135. So 90 and 135 means we're in the second quadrant. The sign in the second quadrant is positive. Okay, you could do this for other angles. Like if I was in the fourth quadrant, you'd go between 270 and 360. That would still put you in the second quadrant, actually, which is interesting. So cosine, -3/5. I got root 1 minus -3/5 over 2. This is root 5/5 plus 3/5. That's minus a negative. So 8/5. 8/5 over 2 is 8/10 or 4/5. So this is root 4/5, which is 2 over root 5, which is 2 root 5 over 5. Rationalize this. 2 root 5 over 5, get that? Cosine, again, we're in the second quadrant. Cosine is going to be negative. The identity is 1 plus cos x over 2. So cos x, again, is root -3/5. So this is 5/5. Again, you guys are probably typing this all into your calculator because you have no confidence in your arithmetic abilities. But like, you need to have them. Like when you get to the AP calculus test, 75% of the questions are no calculator. It's not 50-50. It's like 80-20, 75-25. 5/5 minus 3/5 is 2/5. 2/5 divided by 2 ends up being 1/5. Root 1/5 is going to be -1 over root 5 or negative root 5 over 5. And tangent's the easy one, right, for these halves? 1 minus, sine A over 1 plus cos A. Sine x over 1 plus cos x. Sine x is -4/5. 1 plus cos x is 1 plus -3/5. This ends up becoming -4/5 over 5/5 plus -3/5 is 2/5. This is -4/5 times 5 over 2, which is just -2. The -4 and the 2 cancel. Does that make sense? Being negative. Yeah, if we start in the third quadrant, divided by 2, we end up in the second quadrant. And in the second quadrant, tangent's negative. I'm just thinking about something like that. Yeah. 180 to 360 gives you 90 to 180. Okay. We did this one in class. I gotta skip. This is taking me forever. I can't skip it. I'm sorry. We gotta get to the end. Okay, here we go. We had something similar to this earlier, where it's like you got U and V in quadrant 3. Just draw two examples. Here's example for U. Sine is opposite over hypotenuse, so opposite is -8. Hypotenuse is 17. And then V, I'm in the third quadrant. Let's go down. Tangent is 4/3. That's opposite over adjacent. That's opposite 4, adjacent 3. What's the special Pythagorean theorem? Triple. 15. So this is 15. This is angle U right here. Here's angle V. We know this is going to be 5. We know these are going to be negative. Okay, so from these, you can have sine, cosine, tangents. So if you want to know what cosine U minus V is, you use the cosine, opposite sine, sine identity. That's cosine U. Cosine V plus sine U, sine V. Cosine U, negative 15 over 17. Cosine V, negative 3 over 5. Plus sine U, negative 8 over 17. Sine V is negative 4 over 5. We got this big old fraction. Is that a negative 3? Gosh, it's so ugly, so messy. Can't even erase it. Yeah, cosine negative 3 over 5. Okay, so what's 17 times 5? 85. So I have 45 85ths plus 32 85ths, 77 85ths. Is that right? Sine U plus V. So sine U, cosine V, same sign. Cosine U, sine V. Sine of U, sine, negative 8/17. Cosine V, negative 3/5. Cosine U, 15/17. One thing about the AP test is like all the arithmetic is usually not this intense. It's like using 3, 4, and 5, those kind of numbers. Sine V, negative 4/5. So again, this is 85ths. This is going to be 24 85ths plus 60 85ths. Combine those are 84 85ths. Look at that. That's nice. Tangent. Tangent minus tangent. That's the same sign over 1 opposite sign. Tangent. That's how I remember the double one. Just to remember this one. Okay, so tangent U, negative 8, 7. Oh, jeez, it's opposite over adjacent. Negative 8 over negative 15, which is positive 8/15. Minus tangent V, negative 4, negative over negative 3, 4/3, over 1 plus tan U, 8/15. Tan V, 4/3. Whoa, Nelly. I got to do some common denominator stuff. Sure, whatever. I got it. Multiply top and bottom by 5. This is 20/15. 8/15 minus 20/15 is negative 12/15. This is stuff that like you would have to do. Okay, this is like calculus. This is 32/45. This is 45/45 plus 32/45 is 77/45. Oh, I don't want to do this. So I get negative 12/15 times 45/77. Keep, change, flip. This can turn into 3. Divide this by 5, that's a 9. Oh, never mind. This turns into a 1, this turns into a 3. This turns into 12, 24, 36, negative 36 77ths. Go ahead, do it in your calculator. I dare you. That's the answer. Okay, we did this in class as well. Sometimes it's beneficial to multiply by the conjugate. If you ever see like a 1 plus something, multiplying by 1 minus, that's not the reason why we're doing it here. We're doing 1 minus cosine x because that's going to give it a common denominator to this guy. I'm going to do 1 plus cos x. Now, when I do that, I get 1 minus cos x times sine x plus sine x times 1 plus cos x over. Now, let's think about 1 minus cos x times 1 plus cos x, because it's going to be the same in both denominators, so we'll be able to add the numerators together and just have the same denominator. I think this froze. There we go. Okay. Well, like, this is the whole, like, conjugates multiplying by it. The reason why we do it is because you get, like, 1 times 1 times x, negative x times 1, x times x. You get 1 minus x squared. So in the denominator, I get 1 minus sine squared. Sorry, 1 minus cosine squared. Okay, now, great. What do I do with that? Well, I know 1 minus cosine squared is sine squared. I'm going to do that for a reason. Not this one. This one. 1 minus sine squared is cosine squared. Move the sine squared over 1 minus sine squared cosine squared. So I do this for a reason, so that I see if I have sine squared, and then I have, I mean, if you want to just distribute too, why not distribute? You know, you can, you don't have to. There's other ways to do this, but I think I did this in class. Get sine x minus sine x cos x plus sine x plus sine x cos x. Why did I do that? Because watch. Minus sine x cos x plus sine x cos x, that's gone. Sine x plus a sine x is like x plus x. X plus x gives me 2 x's. That's why. Sines cancel. I get my final answer 2 over sine x. It's a great one. And finishing up, more of these, similar to the ones we already did. This one, I feel like sine over cosine and 1 over sine will help us. They do. Other ways to do this, though. Gives us 1 over cosine, which I would say that's secant. Cotangent, cosine over sine. Secant, 1 over cosine. Cosines cancel. You're left with 1 over sine, which is just cosecant. Tangent. Secant. Cotangent. If you multiply everything across, sines would cancel. A pair of my cosines would cancel. Not everything. It's like, this is cosine squared and the cosine in the numerator. Just one of the cosines would cancel, giving me just 1 over cosine left over, which is secant again. We did it, guys. We did it. This is intense. This is the toughest test that you've seen, that you've had. You can't cheat. It's tough to cheat on these questions. It's like almost practically impossible to. There's no program out there that's going to be able to do this. Like, could you use your calculator to help you? Yes, but it's actually tough to use your calculator to help you, especially for these angles located in these quadrants that are not just like first quadrant angles. This is tricky stuff. You got to be ready to roll. I can tell you one thing. The numbers that you're going to be using are going to be easier than these doozies of 16, 36, 63, and 65. or 20 and 21 and 2 root 6. It's probably more like 3, 4, 5 right triangles and like 6, 8, 10s and 5, 12, 13s. So just those numbers. Do the identities over again. Go back to our homeworks on the don't do the homeworks actually. Do the practice problems on the identities. Go over stuff like that. And I'm here to help you. Good luck out there.